We're going to take a look at how to use molar masses, and don't forget there's a mole in our molar masses, and if we go back to our different conversions we were looking at, these are the conversions that we're going to be working on, so have your periodic table handy. So a molar mass is always going to have the units of grams per mole, and this is letting us relate something we can measure, grams, with something we can count, moles of a substance. So we're going to work some of these and leave some for you for practice later on. Molar mass is going to be the mass of 1 mole of any substance in grams per mole. We find these on the periodic table. Other almost synonyms for this are atomic weight, formula weight, and molecular weight. So recognize if those were asked in a different problem, we're generally talking about find the masses on the table and add them up together. So looking at N2, this says use the periodic table to calculate molar masses for each of these substances. So in N2, recognize that there are 2 nitrogen atoms, right? And so I'm going to go to the periodic table and I'm going to find out what the mass of 1 single nitrogen is, 14.01. Keep all the significant digits off of any number you get from the periodic table. Don't round. Scientists go to a lot of effort to get all those significant digits, so keep them all. So if I want to know the mass of a mole of N2, I need to take that 14.01 and 14.01, and I need to add them together. And that's going to give me, well, I'll put it down here, 28.02. And what do I do in terms of units for that? Well, this would be 28.02 grams per mole of N2. Or a different way that I could write that, I could write it as a fraction, which is more useful as I jump into conversion problems. Grams of N2 per 1 mole of N2. And notice I'm not just writing grams and mole, but I'm writing which chemical it's for. All right, so this would be an answer, and this would also be the same exact number, just written a different way. So I'm going to leave you to try the oxygen on your own. Let's look at this third one here. Now we have nitrogen monoxide. So I have 2 different chemicals. All right, that means all I have to do different this time is find a mass of a nitrogen, one of them, and a mass of an oxygen, one of them, and add them together. So the molar mass here would be 14.01 plus 16.00, and that comes out to 30.01 grams of NO for every 1 mole of NO. All right, so if you're asked to calculate the molar mass, that's how we calculate our molar masses. And again, I left you one to practice here in the middle. What if we want to use those? So remember, we always start easy and then get harder, or use it a little bit differently. So let's check out A here in this quadrant C. So A says convert, so now we're converting or translating 5.55 grams of N2 to moles of N2. So I just want to remind you back in chapter 1 how we solved our problems. First, we wanted to write down what our given and our goal were. Second, we wanted to track down any conversions that we had, and there's always 2 units in a conversion, right? A numerator and a denominator. Then we wanted to set it up and calculate. And then finally, we want to check. So as we work through these couple slides of problems, this is still our problem solving method. So my given, there's only one number given, so that makes it easy to know where to start, 5.55 grams of N2. And my goal is to get 2 moles of N2. So now I want to see, do I have a conversion to get from grams to moles of N2? And I do. I can see those units right up here, right? I don't want to grab the numbers for NO. I want to make sure it's N2 that I'm working on. So if you remember from chapter 1, the numerator units become my denominator units. And then I'm going to pull this end unit back here. Up here, notice in my conversion, 28.02 grams. So that's going to go with the grams in the denominator. I can just flip it upside down. Per 1 mole of N2. So I've got that set up. I'm going to punch it into my calculator, so go ahead and pause and do that. And once you do, you should get 0.198 moles of N2. I'm going to use that rule of 3 for rounding, so the 0 doesn't count, but 1, 2, 3 digits when I report that answer. All right, let's try a second one. Let's go down to D. We'll leave you some in the middle here. So this says convert 1.65 moles of NO. So units and the chemical formula, to grams of NO. So I go, all right, can I go directly from moles to grams? And sure enough, I can. I have that molar mass here. This is my conversion. So moles of NO have to be in the denominator so that they'll cancel, right? And then I can bring the grams of NO to the numerator. So copy carefully. 30.01 goes with the grams, so that would be on top. Moles is 1. When I multiply that, I should get something bigger than 30. Always kind of estimate in your head so you don't just blindly plug it in your calculator. And when I do punch it into my calculator, I get 49.5 grams. So double check that on your own calculator. And sure enough, that mole is bigger than the 30, right? Because it should be about 1.5 times that. So that is some of our simpler molecules and how to use them. And notice my molar masses, depending on how you needed it in the problem, maybe I convert from grams to moles, or maybe I convert from moles to grams. All right, we're gonna take a look at one more harder one on the other side, and then I'll leave you some more of those to practice on your own. So let's take a look right here at B. This is magnesium hydroxide. So I'm looking for molar mass. And so here what I need to realize is that I have magnesium, and then just like we counted when we were balancing, this 2 tells me I have 2 oxygens and 2 hydrogens. 2 O's and 2 hydrogens. So that means when I go to find the molar mass on the periodic table, I'm going to find the mass of magnesium and hydrogen and oxygen. And I'm going to have to multiply by 2 here. So magnesium was 24.31. Then I have 2 times 16.00, and then 2, 1.008. So I'm going to add all of those together. And when I do, again, just keep all your digits for this class, 0.326, and this would be grams per mole for that magnesium hydroxide. So that would be my molar mass here. So that's how your parentheses work. It just gives you a little bit more to add together. Let's try and use that number down here. So now it says convert 0.232 moles of magnesium hydroxide to grams. Follow your units down, moles down here, grams here, because I'm headed to grams, right? Make sure I use the correct molar mass. This was the mass for magnesium hydroxide. So I want to only use numbers that correlate to magnesium hydroxide, 58.326 per mole. And when I calculate that, it should be a fraction, about 1/5 of this 58, right? And I get 13.5, if I round to 3, 13.5 grams of magnesium hydroxide. Again, if this tight space is hard for you, just do a whole page for each of these. Spread it out and just attach it to your notes. So that was finding the molar mass of something a little more complicated, and then using it just like we did over here to find a mass. So I've left you some to practice, and we'll go over some of those and practice them in class also.